Thanks, Jamie. Hello from Nipaluna, Hobart. The format of these briefings has typically been we start off with something interesting that's going on in the ocean, then go through to the seasonal forecast. And over the last year, we've talked about the adaptation options and the intervention options that users of the ocean have, both as managers and planners and resource users. And today we'll go through the first two parts of that, and then Mel Coleman will talk about one particular application of marine heatwave planning that's happening in New South Wales. As usual, on the FRDC homepage, you'll be able to see the recordings of this briefing after the meeting, and then also the previous ones are there as well. Last time in this introductory section, we talked about how we were tracking this year and then also looking towards 2040, which is not very far away. And then we had some reflections on last summer. Those reflections on last summer led to the question of how does this year compare to El Nino? And so we put together these slides here that just show you for a selected day in December in 2016, December in 2023, and December in 2024. 2016 and 2023 summers were strong El Nino summers. And you can see how much marine heatwave conditions we had around Australia in 2016. This is the 2015-16 summer. We already saw the intensification off Tasmania and again off northwest Australia. In the El Nino of 2023-24, you saw very strong warming off the east coast in the Tasman Sea and again off Tasmania. So those two El Nino years were a little bit different in the expression in December. We could look through to February and see what the differences were, but here we've just focused on the current period of time. Now we contrast the year 2024 that we're in now. It's not an El Nino year, but the pattern of warming looks a little bit more intense than we saw in 2016. We've got both the northwest shelf warming still occurring, as well as the Tasman Sea and the hotspot off Tasmania again. I guess the point of having a look at this one, if you remember how you were impacted in 2016 and 2023, 2024, though it's not an El Nino year, is still looking like it's going to be pretty warm, and that warmth has continued in the northwest and around Tasmania. This was an example of the kind of response we can provide to questions that you have of us. So again, when Jamie asks at the end, are there other things that you'd like to know more about, we can go away and do a bit of, I call it limited research, to bring back to you in the next briefing.
Alrighty, thanks, Alistair. Hi, everyone from Melbourne. So we'll step through the current ocean conditions to give you a bit of context, and then we'll look forward for the next, say, 3 months, so through to Christmas, January, and then February. We've mixed up the format a little bit this time based on some feedback we got from their last presentation. So very happy to hear if you love it, you hate it, something else would be useful. So I'll get started. So the recent conditions around Australia, so October and November this year were the hottest on record for Australian waters as a whole. On the left here, I've got sorry, my lights are dimming. On the left here, we've got the deciles of sea surface temperature. This is a very top layer of the ocean, and it gives an indication of what's been going on. So you can see for most of Australia in November, with the exception of the Gulf and the Great Barrier Reef, northern New South Wales, has been very much above average. So the top 10% of November temperatures, sea surface temperatures in that region. It has been cooler in the Gulf. Well, it's all relative, right? It's in the top 20% of sea surface temperatures recorded. So it's been very warm in November. It's been very warm in October as well. So that is priming the system as we head into summer. If you look at it in context since 1900, using the extended reconstructed sea surface temperature from NOAA in the US, you can see this is basically the average of the sea surface temperatures from the map. We're way up here. So this was for November. Obviously, it depends on where you're looking specifically, and your particular patch may not be record breaking, but it's been very warm. We then step out and look at the global context. You can see over here in the Eastern Pacific, we've got this blue, which indicates cooler than usual conditions. So this is a similar pattern to what you'd see during a La Nina. Now, based on the different indicators that the Bureau looks at, it is not a La Nina event. It's just that cooling there is what you would see in a weak La Nina. So that will affect the oceans around Australia, even if it's still classified as neutral. You can see those patterns that Alistair pointed out in the daily temperatures there. Very warm on the northwest shelf. This is for the last week. Very warm in the Tasman Sea. So round down Tassie, off New South Wales, and stretching out across to New Zealand. Also warm, as we were talking before we got started, warm heading into the Bight as well. Okay, so if we look at the marine heatwave conditions, so this data that I'm showing here is what we use to start our forecast model off with. So we take the Bureau takes all the observations in the ocean that we've got available today. We stitch it together to make a best guess of the ocean state today, and that's what we start our forecast with. The better we can capture what the ocean looks like, the better the forecast. So this is marine heat wave conditions here. These are based on sea surface temperature, again, so the top 1 metre of the water column. You can see that warmth is showing up here. This is the last week as well. Northwest shelf, moderate to strong marine heatwave conditions. And you can also see the Tasman Sea here is lighting up as marine heatwave conditions. The metric you use only looks at the top 10% of sea surface temperatures. Once you tip over that threshold, you start going into marine heatwave. And you can also see that area here past Spencer Gulf and heading into the Bight, also in actually in strong marine heatwave conditions on inshore, and warm extending offshore as well. The other piece of information that we look at, which is obviously fish and coral are not in the top 1 metre of the water column, is looking into the subsurface. So what I'm showing here is down to 300 metres. It's essentially how much heat is in the top 300 metres of the ocean. So if you have a very thin layer that is very warm, you get a nice strong sea breeze in a few days in a row, you can really cool that down. But if it's hot all the way to the bottom, to the shelf, or deeper than that, it's very hard for a couple of windy days to mix that heat away. So you can see on the northwest shelf here, anywhere that's red is much warmer than it would normally be for this time of year. Anywhere that's blue is cooler. So you can see there's eddies hanging around, especially off the west coast. But in the northwest shelf, offshore, it's very warm down to 300 metres. It's also very warm heading into the Tasman Sea. So that means that heat is going to hang around. Okay. So the other thing we look at is how well, so we had the last briefing was on the 1st November. These were the couple of forecasts that Grant presented last time, which was the forecast for the end of October, start of November, and then for the middle 2 weeks of November. So how well did we do that? So top 2 of the forecasts, they were the fortnightly ones, and the bottom 2 panels are what we actually observed using satellites. So you can see that the model picked up that northwest shelf heating, both those fortnights, and that is what is observed. Possibly didn't quite get the high magnitudes across the whole region, but it certainly indicated they were going to be very warm throughout November. It also indicated heating through the Bight, and that's what also was predicted as well. Oh, sorry, that was also what was observed. Warm off Tassie, off the east coast, that also was seen, and then also warm down New South Wales coast. So the model did a pretty good job. Admittedly, we weren't trying to forecast 6 months ahead. We were forecasting essentially a month ahead, but it's showing the model was providing useful information. It's always good to go back and check that the forecast that we gave actually was what we saw in reality. Marine heatwave forecast. So this was November as a whole. You can see that, so these are flipped around. On the right is the forecast. So we predicted northwest shelf marine heatwave conditions, also off New South Wales and down the coast of Tassie. Now on the left is what we actually saw. So the patterns are correct. We didn't get the magnitude of the marine heatwave. So it's actually, we saw a strong marine heatwave on the northwest shelf in November, but there were certainly warm conditions, and that's what the model predicted. Same for off Tassie, that did a pretty good job, and also those marine heatwave conditions through the Bight. Okay, so stepping forward. So I've got December through to February. Obviously, we're halfway through December, so I'll take you through to Christmas and then the 2 months following that. I guess that's an opportune time to remind everyone that the further out we're trying to forecast, the less confidence we have in the forecast. So the model usually has higher skill or higher accuracy at shorter lead times. So month 1, month 2. That's why we're not showing you 6 months worth of forecast, because too many things can change in that time. Okay, so looking at the global picture. As I said when we were looking at the observations, this is out in the Eastern Pacific, this is one of the regions and one of the indicators we look at when we're talking about ENSO. So the Nino 3-4 index is just basically the average ocean temperature in this box at the surface. And that's one of the things the Bureau looks at when we're determining whether a La Nina, an El Nino, or neutral conditions are currently in play. So this is not strong enough to be considered a La Nina, but it is La Nina-like. But you can see very warm conditions. This is the forecast for the next 3 months. This was issued at the end of November, but you can see that heat that we've been seeing in the last few weeks is predicted to hang around, particularly Northwest Shelf, southern New South Wales, and down to Tassie and across to our Kiwi neighbours in New Zealand. If we talk a little bit more around ENSO or El Nino or La Nina, the Bureau's status at the moment is neutral. So that means neither one or the other. So we have seen a few things that look like La Nina, but haven't actually crossed over to the threshold. And our model indicates that it's going to stay like that through to at least April. We also look at other international models from other institutions around the world, and 4 out of 6 of the ones we looked at have suggested the same thing. So neutral conditions through to April. 2, one being the NOAA US model, has indicated a weak La Nina, but on the balance of evidence, we would say that's unlikely, and if it does happen, it'll be weak and short-lived. The IOD, which is the Indian Ocean Dipole, so that's affecting more of the west coast of the country, is neutral, and that's what we would expect this time of year. It's usually active heading into summer, and by December usually breaks down the Australian monsoon onset. So that's what we would normally expect. Okay, so the next 2 slides are rainfall and air temperature. And so the reason we show these, if you think about it, so if it's really wet, there's lots of cloud hanging around. It gives the chance for the ocean to cool down because you don't have clear sunny days with the heat coming in from the sun. And also air temperature, because that gives you an idea. The land's really warm, the ocean's really warm. It just gives you a bit more information to kind of make that picture of what to expect in the next few months. Also, you know, if you've got your obviously got your processing plants, transport, all those supply chain aspects for your operation, that's all going to be land-based as well. So it's worth having a bit of a look and see what's going on. So for the rainfall outlook, what I'm just showing here is the chance of being above median. I did look at the extreme rainfall forecast. There wasn't really much to show here. So it's wetter than normal in December. For the west, you can very much high chance of it being wetter than normal up here in the northwest, and considerably drier than normal in the southeast. But it wasn't tipping over into that top 20% of really wet or top 20% of really dry. So that's why I've just shown these above and below median. This is for the rest of December. This is going through to New Year. On the right-hand side, I've got the same plot for January and February, and it's looking pretty average based on the current forecast. So this was released, I'm just looking for the date, on the 11th of December. So likely to be a bit wetter than usual in Queensland. So that comes with cloud as well. Bearing in mind, we can't predict tropical cyclones in this model. So it wouldn't give an indication if there was, you know, a large dump of rain due to a cyclone. But for the rest of the country, looks like a pretty average January and February in terms of rainfall. If we look at air temperature, so this is just over land. Again, you can see if I flick between the two, you can see that really dry next 2 weeks over the east coast coincides with really warm. So in this slide, what I'm showing is actually the chance of being in the top 20% because we were lighting up on all these maps. So I'm like, well, let's show that. So very high chance all down the east coast for the next 2 weeks of it being in the top 20% of air temperature. So that's pretty warm. WA, looks pretty much average. January and February, quite a lot of the country has an elevated chance of it being extremely warm in terms of air temperature, particularly through Queensland, parts of the Northwest Shelf, and then heading into February for those based in Perth or WA, increased chance of high air temperatures, so a pretty warm February. Okay, getting into the water. So the next 3 slides I've revamped, but happy to take feedback. So what we've got here is for the next 2 fortnights. So previously we had sort of stepped through each. We'd step through sea surface temperature, then marine heat waves. And the feedback we got was people like, I can't remember what you had on the last slide and how that fits with this slide. So I've grouped it by sort of time period. So across the top 2 panels here, SST anomalies, so warmer or cooler than normal. Anywhere red is warmer than normal, which is pretty much the going status these days. Anywhere white is what you'd normally expect. Anywhere blue is cooler. So we've got the 9th to 23rd of December on the top panel, on top left, and then the following fortnight on the right. So same areas lighting up, Northwest Shelf, parts of the Bight, New South Wales coast down to the east coast of Tassie and then across the Tasman as well. So that heat is predicted to hang around for the next 4 weeks. As a reminder, on the left, it's always important to look at how good the model is. So what we do to assess that, we run it for 40 years. And we look back and see how well the model do in other summers. And it varies from location and time of year. But the takeaway from these 2 plots here, anywhere green, the model does a good job at this time of year for these 2 fortnights. So we've got good skill and we're confident in these forecasts. The bottom 2 panels are marine heatwave category. So where is it hot enough to tip over that top 10% to be classed as a marine heatwave? Again, same areas lighting up. Northwest Shelf, moderate to strong, if you can see my mouse, moderate to strong marine heatwave, through the Bight and also parts of the east coast. Coral Sea starting to light up too. I'm just going to move my machine so I can see the side of the slide. And that pattern continues for the next fortnight as well. These bottom 2, I'll put the little star next to them, they're trial forecasts. The others are available online publicly, and I've got the link there. These 2 are works in progress, and we're working to get them to make those publicly facing as well. Okay, so now we're going to look to January. So warm heading into Christmas. This top one here is our SST anomaly. So you can see Northwest Shelf, still warm. Southern New South Wales, parts of Victoria, Tasmania, still warm. And also quite warm in the Coral Sea and through the Bight. So our model skill is down here. And you can see that these white patches are where we don't have skill. Often that's because there's lots of eddies around. It's really hard for the model to get those eddies in the right spot. But you can see for most of the WA coast, through the Bight, Victoria and Tasmania, the model does pretty well. There's parts over here that have lots of eddies and lots of ocean activity going on that we don't do a great job. But overall, we don't do too badly for January when we're trying to predict it from December. Okay. So now if we look below the top meter into the water, top 300 metres, you can see that heat going all the way down to 300 metres on the Northwest Shelf here. So that is why it's so persistent. It's hanging around because it's warm all the way down. It's also very warm off the shelf going into the Bight. And then you can see this heat here as well. Southern New South Wales, parts of Victoria and Tassie. Coral Sea, there is a bit of warmth here just off the shelf, but it does back off as you head eastwards into the Coral Sea. If we take that information and then we go, right, how extreme is it? Are we talking marine heat waves or are we just talking a bit hotter than normal? This is what we've got here. So these match up all for January. On the top right, this is a chance. What's the chance of being marine heat wave? So when we run our model, we run it every day. We run it 99 times. And we look at how many of those forecasts actually tip over the marine heat wave threshold. And that gives you an idea of what are the odds? What's the likelihood of it actually happening? And unsurprisingly, you can see here in the Northwest Shelf, we've got 80 to 100% of our forecasts are saying marine heatwave conditions. We can also see parts of the Coral Sea through the Bight here and off Tassie, very high chance of marine heatwave conditions. If we look at its sort of partner plot here on the bottom right, this is just taking all that forecast information, averaging it and going, okay, what does that look like? Marine heatwave conditions in all those locations. Moderate but widespread. So you can see all the way offshore, full sort of northwest coast and offshore, through the Bight, Coral Sea and off the coast of Tassie. So that's for January. So you can see how those pieces fit together to give that story for January. If we go forward a bit further into February, it's a similar story. So we're still seeing heat in the same locations. So still Northwest Shelf, still very warm, extending offshore and now extending south. And if you remember from the air temperature forecast that we looked at, Perth was going to be cooking in February. And you see that here the ocean is also very warm. So that makes sense. Eastern Tassie, Coral Sea, parts of New South Wales and the Bight, still warm. Not as high as it was in January. So these anomalies are all relative to that time of year. So this is how much warmer is it than in February than you might normally have. Looking over here, how well does our model do for February when we're trying to predict it from December? It does drop off. But you can see, if you can see my mouse, I've lost my mouse. WA through the Bight, this area here of New South Wales and Tassie, and also Northern Coral Sea. The model does a pretty good job. So we've got reasonable confidence in what the model is showing us. The caveat is, if you get a nice strong tropical cyclone coming through Northern WA or through the Coral Sea, that will significantly cool things down. And that's something the model can't predict at this point in time. So as we get closer to those kind of active times of year when you see a lot of cyclones, you need to keep an eye on what's going on in your particular part of the world. Popping into the water, same story. That heat is hanging around Northwest Shelf, down off the southeast coast and through the Bight. Some heat in the Coral Sea, but not quite as much as we were seeing in January. Now, does that translate to a marine heat wave? So our likelihood of marine heat waves conditions has backed off. So in January, this was all dark green. So there are still areas showing here 80 to 100% of the forecast saying marine heatwave conditions, but it has backed off to some extent. Same for the Coral Sea, though it's more widespread. Tassie still high probability, and also reasonably high probability through the Bight. You can see the translation of that when we take all that information and average it up, still marine heatwave conditions, Northwest Shelf. I sound like a broken record, but basically that's the story. Northwest Shelf, Eastern Tassie, parts of the East Coast, sustained marine heatwave conditions for the next 3 months. And I think that's it. Thanks, everyone. I'll pass over to Mel now. I'll let you introduce yourself, Mel, and I will drive the slides for you.
Thanks, Claire. Hi, everyone. Nice to meet you all. Yeah, my name's Mel Coleman. I'm a Senior Principal Research Scientist with Fisheries based up in Coffs Harbour, and I lead the Climate Change Research team. And today what I really want to talk to you about is what we're doing within Fisheries to prepare for and to respond to marine heat waves. Next slide, please, Claire. Thanks. So just, I suppose, setting the scene a little bit, I just wanted to point out that marine heat waves are a very common feature off the coast of New South Wales. This is just a little bit of a snippet off northern New South Wales and southern New South Wales, and when we've had marine heat waves over the last decade. And you can see that these are occurring all the time, every year, summer and winter, of various sort of intensities and frequencies. But what we do know is that, you know, going forward, marine heat waves are projected to continue to increase in intensity and frequency. So we're going to see more of these sort of extreme events like I've sort of circled in the bottom picture there, and more of these sort of increasing frequencies of events like what we saw last sort of summer and spring off the southern coast of New South Wales, which makes it super important to think more and more about how we're going to respond to these events. And within New South Wales Fisheries, we have been doing this for quite some time. We have a very strong research and development focus, and we've been doing climate change and marine heatwave research for over a decade now. And some of the things that we've been doing include long-term monitoring of our, fish and marine habitats. Of course, to be able to measure climate and marine heatwave impacts, we need a really solid baseline from which to measure those impacts. We do a lot of lab experiments. We have great facilities to be able to simulate marine heatwave conditions so that we can try to understand how organisms might respond. We also do a lot of modelling and projections to, I suppose, gaze into that crystal ball and try to understand what our future oceans might look like. And we're sort of doing all this research not just on the abundance and the distribution of species, but we're really interested in these sort of sublethal aspects as well. So looking at the adaptive capacity of organisms through their genetics, looking at physiology, but also some really cool stuff like looking at how marine heat waves and climate change might alter seafood taste and nutritional properties as well. And so really, it was the advent of these forecasts and these briefings last year, though, that prompted us to develop this New South Wales Marine Heatwave Response Plan. And this is essentially our sort of document that guides the actions that we take as a department at each stage of a marine heatwave cycle. And it really is a bit of a first. When we decided to write this, we couldn't really find any similar plans for other state government agencies in Australia or around the world. There were a lot of coral bleaching plans that we were able to draw sort of expertise from, but a lot of this we kind of had to sort of develop on our own. And so I'll run you through the different components of the plan. There are essentially, I suppose, four main components. We have this early warning system, which is the stage that we're currently sitting in now. We have a response level assessment, and then we have these response actions when we have an active marine heatwave and sort of biological indicators of thermal stress. And overarching the whole plan is a communication strategy, which I think is one of the most important parts of the plan and also kind of feeds into all of these other components. And so the first of these components of the plan is this early warning system. And the early warning system is a combination of us sort of monitoring both the forecast and the real-time conditions in the ocean from the spring through to the autumn. You know, we're looking at things like the sea surface temperature anomalies and the marine heatwave forecast. You know, we're using the same online tools that all of you have access to and that you've seen in all of these briefings. Once marine heatwave conditions do develop, then we're also on the lookout for these rapid biological indicators of thermal stress. Things like out-of-range species presences, fouling or discoloration of algae and of kelp, coral bleaching, mushrooming and signs of stress in things like abalone, mortality of individuals, or, you know, things like increases in the occurrence of disease or algal blooms. And it's not just the researchers within fisheries that are sort of on the lookout for these indicators, but we really urge everyone that's out there with eyes on the water to kind of watch out for these signs of stress. You know, wreck divers and fishers, industry, other marine managers, citizen scientists. It's great for everyone to be on the lookout for these indicators and also to report them to New South Wales Fisheries. So once we have an active marine heatwave and we start to see these signs of biological stress, we move into this response level assessment, which is really what guides then the types and the number of responses that we will take or that we will implement. And so this is quite a classic sort of or a typical risk sort of analysis framework where we're combining the marine heatwave category with the number and the types of biological indicators of thermal stress to sort of define these three main response levels, response level 1, 2, and 3 in the red there. And there's sort of this increasing level of intervention as we go from response level 1 through to response level 3. So these are some of the examples of the response actions that we might be able to take. And again, they're sort of grouped by colour into response level 1, 2, and 3 with this increasing level of intervention. And I won't go through them all in detail, but in a nutshell, response level 1 might include things like increasing science, increasing research, doing more engagement, and facilitating industry to autonomously adapt to marine heat waves. Once we start moving into response level 2, we're talking about things like increasing communications, mobilising people and resources to start to take these actions, and strengthening sort of existing regulations that we already have in place. And then response level 3 is sort of this highest level of response, or the highest level of intervention. And we're sort of starting to talk about emergency regulatory interventions and emergency translocations. And one example might be temporary spatial or temporal closures, for example, in the footprint of an active marine heat wave. Still a lot of work to do in that response level 3 area, and we're definitely working with existing processes and regulations that we have within the department to try to prepare for marine heat waves. It's also really important within this response action space to think about what we do after a marine heat wave has passed, and there's been quite large impacts, and so recovery actions, so what we can do to support the recovery of species and industries is really important. We're also continually reviewing and improving this plan. We're learning new things, every time we look at it, basically, and we've certainly learned a lot over the winter months, and you're seeing some new changes to the plan here as well. Going forward, we're also really interested, particularly in this response level 3 sort of area, to start to embed marine heat wave preparedness and responses, as I said, in these sort of existing sort of formal processes like harvest strategy revisions and the setting of quotas. And this sort of final part of the plan that feeds into all of the other components is our communication strategy. We have quite a full communication strategy that our comms team actually wrote that sort of sits behind the plan. But this is really important because what it does is it ensures that credible, consistent, and accurate information is communicated to our stakeholders at all stages of the marine heatwave cycle. And so some of the things we did last year were social media posts, and there's an example there on this slide showing you, I think it was Facebook or Instagram sort of feed. Newsletters, we did media releases, which then resulted in some television and radio interviews. We had some seminars and briefings with different stakeholder groups, and also just made use of all those informal contact systems that we had, regular meetings with different stakeholders and managers to talk about marine heat waves. So this sort of spring and summer is obviously the first time we've had the opportunity to really enact the plan. And we're currently sitting in this early warning system. So just like everyone on this call, we're sort of monitoring these forecast and real-time marine heatwave conditions and sea surface temperature anomalies. And we've sort of already started to be on the lookout for any indicators of thermal stress. And we've put out a media release, sort of a bit of a call for everyone that has their eyes on the water to consider sort of looking out for some of these impacts if a marine heatwave does develop. We've also had some increased sort of scientific activity along the coast. So thanks to the integrated marine observing system, we have a couple of these gliders here, this contraption in the yellow, which are sort of going up and down our coast at various depths to characterise a whole bunch of sort of temperature and other environmental conditions in our oceans. And they are also on standby should a marine heatwave develop to get in there and to learn more about these extreme events. We've had a couple of newsletter articles as well about the gliders, and most of this media has been sort of having the dual purpose of informing people about the likelihood of heat waves, but also educating people about what we're doing and what marine heat waves are. So one of the things that really became apparent to us sort of revising this plan over the winter months was the need to really start to drill down for specific industries and start to develop these industry-specific plans. So as a starting point, we've begun with the abalone industry. Abalone are obviously a particularly vulnerable species, being sessile, so unable to escape these sorts of conditions, but also being a live industry. And so over the winter months, we've done a lot of consultation among industry researchers and also our managers. With industry, we've been doing things like learning and identifying early warning signs of heat stress, looking at how they're already autonomously adapting to marine heat waves and other climate stresses, and learning about and thinking of ways that they can improve communication systems for when marine heat waves do occur. We've also been thinking about what response actions can be taken by DPI during heat waves for the industry, and how we can help them to adapt. And it really has been a fantastic process. We have had nothing but overwhelming support so far to uptake some of the recommendations in this plan in the standard operating procedures of the industry and their diver code of practice, and within DPI to start to really consider marine heat wave preparedness in the harbour strategy revision process, which will be occurring next year. And going forward, we're really excited to apply these learnings to other industries and really ensure that everyone in the marine estate is prepared for marine heat waves.
Thanks, Mel. That was great. It was really good to hear about, how this work is being applied in practice. So just to wrap it up, I just wanted to remind everyone of your friendly FRDC Extension Officer network, who are also a great source of information for what's going on in your particular patch. So the list is there. We'll also circulate the slides, so if you miss it on this round, you'll be able to have a look there as well. And just to wrap up, just wanted to point out that the briefings are all recorded and you can find them online. The ocean temperature outlooks are available through the Bureau, so they're the ones we showed. And that we've got 3 more briefing dates to put in your diary over the summer. So we've got one in end of January, one in mid-March and one in early May. And just wanted to thank you all. Please pop your questions into the chat for us, as well as any topics that you'd be quite interested to hear a bit more about, whether that's applications or whether it's just cool stuff happening in the ocean that you'd like to know more about. And if we don't get the opportunity to say it to everyone before you disappear, hope everyone has a safe Christmas and a happy New Year. So over to you, Jamie.
Thanks.